right, so good morning, guys. Today, we're starting the 5th lesson for our 2nd unit, and we're almost done, right? Today's Tuesday. A week from today, we're going to be done, right? Today's lesson is problem with inequalities. So it's going to be really similar to what we did yesterday with equations, except that now we're looking at inequalities, right? So if you kind of got what we did before, then hopefully today's lesson isn't too challenging for you, okay? But again, I'm going to start from the top. Again, the lesson is problem with inequality, so try to go ahead and follow along in Edmentum with me. And we're going to start with the objective, right? So objective for today is that in this lesson, you will study solving an inequality as a process of answering a question, right? So can anybody just give me some feedback, either verbal or in the chat? Right now the chat is set to just host only, on what exactly does this word inequality mean? Does anybody remember what an inequality is? Just give me a yes or a no. You can also use that nonverbal yes, no button on the participant's pane. Okay, so I'm seeing some no's. Again, just a real quick yes, no, so I can kind of gauge the room. Okay, I'm seeing some people use the buttons as well, so I see a yes. Just wait for feedback from a couple more people. No. Okay, good. So I'm seeing so far more no's than yeses, which is good because we're reviewing that now, and then hopefully when you guys go into 7th grade, you'll have a better understanding of what an inequality is, right? But yeah, Alfie's pretty much on the money. Alfie said not equal, so pretty much when we talk about inequalities, it's something that isn't equal to each other. But we have to actually make a slight discrepancy. So if we look over here, this is kind of a visual to help you guys try and visualize that a little bit more, right? So left-hand side, we already know what equal means, right? I think I've also showed you guys this symbol already. This symbol here, an equal sign with a line through it, means not equal, right? Now, when we talk about inequalities, the examples of inequalities that we typically talk about focus first on the left-hand side. So we typically say that greater than or less than are 2 examples of inequalities, right? These are the 2 that we're going to focus mostly on today. You do also have other 2, which are greater than or equal to, or less than or equal to. And it's really easy to remember which is which, right? So when you're thinking about greater than, usually, hopefully you guys aren't too young to know who Pac-Man is, right? Does everybody know who Pac-Man is? Little yellow guy. He's just a circle with a mouth. He eats things, right? So Pac-Man, right? He eats things. Let's say this is Pac-Man's mouth. He's always going to face towards the thing that's larger because he wants to eat the bigger thing. So if I'm talking about a greater than sign, I would have the larger number on the left. So I could say maybe 9 is greater than 7. That's a correct inequality. Or if it's facing the other way, we call this a less than sign. But again, he's still going to face towards the larger number. So it's going to say, let's say, a way that I could write this inequality is I could say maybe 6 is less than 10. So your inequality sign, the open part, or think about Pac-Man's mouth, always has to face towards the larger number. And the idea is that we're going to see statements, and we have to decide if those statements are true or false based on what we see with the variables there, right? But that's just a real quick overhaul of inequalities, and then we're going to get into the lesson today, okay? So again, they're always going to start with some type of scenario that they give us. So the scenario for today is about skiing. So it says here that Kevin is skiing with his family. His parents, Arnold and Vanessa, are skiing enthusiasts. Kevin also has a brother, Devin, and a sister, Lori and Celia, that don't really have a lot of skiing experience, right? This is Kevin's 3rd time skiing, so he thinks that he's going to be a little bit better than his siblings, right? And he's going to try to keep track who can ski for the longest amount of time without falling, right? So to see how good he is, what he's saying here is that he wants to know if he skied more than twice as long than one of his sisters, right? So this type of language here, where we see more than, right? That's an example of what we're going to call an inequality. If it said instead, Kevin wants to know if he skied twice as long as his sister, that would be an equality. So Real key symbols or keywords that tells you you're going to deal with an inequality is when you see words like more than or words like less than, right? Because remember, those symbols, more than or less than, were the inequalities that we talked about. So it says that his dad tells him he can use an inequality to do that, but he hadn't used inequalities before, so that's what we're going to practice looking at today, right? So main thing to remember first is that we talked about equations before, right? We talked about equalities, and when you're thinking about an equation, you think about it like a scale. So if I have something like, you know, I know that 10 is equal to 5 plus 5. If we're thinking about a scale, that scale would be balanced. So, whoops, that is not correct. 5 plus 5, right? If I'm thinking about these two statements, they're equal to each other. So this equality here is true, right? And it's easy to see because both sides are equal. But when we talk about an inequality, we're comparing things that aren't the same size, right? One thing is going to be bigger than the other thing, and we say that an inequality is true kind of if it's just pointing in the right direction. So over here, it gives us an example over here. It says, let's say we talked about this equation here, right? The equation x plus 12 equals 32. We know what that's saying. That's saying that, okay, so basically kind of this statement here on the left, x plus 12, in order for this equality has to be true, it has to give me the answer of 32, right? So really quickly, if you can't see it, I know in that case, the only value of x that would work is going to end up being an x value of 20. So if I took 20, added 12 to it, I would get 32. It's about the same thing when we see inequalities, except we're trying to figure out, again, what makes it true, and usually with inequalities, you do have multiple results. So in this case here, it says 3x minus 7 is less than, that's how I read this symbol, right? It's pointing that way, less than 48. So this here is, again, an example of an inequality, right? So I would, again, try to say, okay, so what value of x makes it so that when I multiply it by 3 and subtract 7, I get a number that is smaller than 48. And we're going to kind of discuss how we do that today, right? We're actually not solving them today, but we're going to be doing exactly the same thing we did yesterday, which is substituting in values to see when they work and when they don't, right? So again, over here, they're just going over those symbols that I showed you already. So this one is less than, this one is greater than, right? One more way to try to remember the difference is if you look at the less than sign, right? This is less than, and you think about kind of rotating it a bit, it's facing the same direction that an L does, right? So the less than side, kind of think of it like an L, so L for less than. The other one isn't facing the right direction, so that one's greater than, right? But try to remember which symbol is which. That's going to help you a lot in the future, right? So again, with inequalities, we try and figure out when an inequality is true or when an inequality is false. So this example that they're giving us here, they're saying, okay, let's look at the inequality 5x plus 12 is greater than 50. So the idea is we're going to try to figure out, okay, so when does a value of x make this inequality true? So for example, right, let's just say I picked a big number. Let's say I picked, you know, a number like x is equal to 10. So if x were to equal to 10, I would just evaluate this left-hand side. I would say, okay, so 5 multiplied by 10 plus 12, is that greater than 50? I know 5 times 10 is 50 plus 12. I already know that has to be bigger than 50. So this would, in fact, give me 62 is bigger than 50. So this is an example where I would say, okay, so that is a true inequality because 62, right? Remember, this sign always paces towards the bigger number, is in fact bigger than 50. So that's a true statement, right? Now, on the other end, sometimes when we're dealing with inequalities, we see false statements. So if I were to pick a smaller number, let's say I picked a number like x equals 1, right? Again, the inequality was 5x plus 12 is greater than 50. I'll do this one a little bit faster. So if x is equal to 1, this is really just going to simplify down to 5 plus 12, which is definitely not bigger than 50, because now this open end, the mouth, is facing to the smaller number. So this here would be an example. I would say, okay, so the inequality is false here if x is equal to 1, right? So again, really similar to what we did yesterday. The only thing that we're doing now is, instead of trying to see if the two sides are equal to each other, we're trying to see if the inequality is pointing in the right direction to give us a true or a false statement. But in essence, it really is very similar to what we did yesterday with those. Okay, good, right, Jaden. So the thing with inequalities is you're gonna have multiple solutions. It's not like an equation where you only had one value of x that worked, right? Jaden said, can't we multiply it by like 100 and that would work, right? If I did, for example, x is equal to 100, I'd say, okay, so 5 times x plus 12, is that bigger than 50? 5 times 100 is going to be 500 plus 12. That is definitely bigger than 50, right? So this, again, is going to have multiple solutions, right? We already know that x equals 10 works. We know that x equals 100 works. Can anybody think of any other values of x that would also work for this inequality here? Would a bigger number work? Do you think a number like, say, you know, x equals 1,000? Is that going to work? Or what about something in the middle? Is something like maybe x equals 13? Is that going to work, right? That's the idea with inequalities, is that you end up with a lot of solutions. And ideally, you guys should have seen this in the 6th grade, but you actually have an infinite amount of solutions for inequalities, right? You can always find more and more solutions. All right, so we're gonna watch a quick video here that's gonna kind of explain what I showed you guys on the last page. So just try to follow
Remember when we discussed inequalities, we brought up the whole idea of a shark's head and related that to the greater than, less than symbol.
Right, so instead of thinking about Pac-Man, they're thinking about a shark head here, right? So think about the mouth of the shark is trying to eat the larger number. Same concept.
Let's take that a step further. Let's take a look at some inequalities and a method to solve them. Look at the inequality. 2x plus 7 is greater than 12. Which of these numbers makes the inequality true? 1, 2, 3, 4. First, try plugging in 1 for x, and then simplify the left side of the inequality. 9 isn't greater than 12. 1 does not make the inequality true. Now, try plugging in 2 for x, and simplify the left side of the inequality. Since 11 isn't greater than 12, 2 does not make the inequality true either. Next, try plugging in 3 for x, and then simplify the left side of the inequality. 13 is greater than 12, so 3 makes the inequality true. Finally, try plugging in 4 for x, and simplify the left side of the inequality. Because 15 is greater than 12, 4 makes the inequality true. To solve any inequality, plug in the possible values and discover which value or values makes the inequality true.
Right, and again, like I said before, with inequalities, unlike equations, you are going to end up with multiple solutions, right? And in fact, you have infinite solutions. So in this case here, you could try yourself. You could check the number 5, you could check the number 6, you could check the number 7. All of those are also going to work, right? If you started going in the opposite direction and tried like maybe the number 0, the number -1, nothing else going that way is going to work. And if you guys remember in the 6th grade, when you do talk about solving inequalities, you learn that you draw your solution on a number line. So it would be, you know, any number bigger than this value is going to give us a solution. All right, so again, this page here is really just, again, reviewing that concept that we already talked about. So if we're looking at this inequality here, 15x plus 4 is greater than 108, they're saying, okay, so what about this value x equals 3? Does that make this inequality true? So 15x plus 4 is bigger than 108. So if we're saying x is equal to 3, again, all that means is replace the x with the number 3. And then you follow the order of operations. So 15 times 3 is 45, plus 4, that's 49. Is 49 bigger than 108? No. So this here is a false statement. So we say mathematically, x equals 3 does not satisfy the inequality. That's a precise mathematical way of saying it. Or you could say also that x equals 3 is not a solution to the inequality, right? But either way, we know that this number 3 doesn't work for this here. And again, we're not focusing yet on solving these inequalities because there is a mathematical way to figure out exactly what values of x work. Today, we're just working on substituting in values to see which ones work, right? If you know how to solve them, that is great. So now, same inequality, 15x plus 4 is bigger than 108. And now we're checking the value of x equals 7, right? So if x was equal to 7, we'd say 15 times 7 plus 4, is that bigger than 108? 15 times 7 gives us 105, plus 4 is just barely bigger, right? So 109, whoops, is bigger than 108. So this here is an example of a true statement, right? Something that it doesn't talk about here, I just want to bring up, is a special case, right? So let's say that I have the inequality, we'll say x plus 3 is bigger than, we'll say, 7, right? What happens if I say, for example, x is equal to 4? Just based on what you think, what we've gone over so far, I want you guys to just type in the chat, what do you think? Is this going to give me a true statement or a false inequality when x is equal to 4? So I'll give you guys a minute to think about that one. I'll put a timer up, and then I'm just going to share what everybody thinks. Again, chat is set to host only, so just type what you think so I can get a gauge of what everybody thinks. Again, just true or false. Okay, that's right, Sissy, right, Jaden. So anybody that's not sure, again, we're looking at this inequality here. X plus 3 is greater than 7. If x equals to 4, is that statement going to be true or is that statement going to be false? Okay, right, Alfie. Okay, we got a couple seconds left. Okay, so let's see what happens if we try this, right? So if x is equal to 4, again, all we're doing is replacing the value of x. So I would say, okay, so 4 plus 3 greater than 7. That gives me the statement 7 is greater than 7, right? Now I'd say, okay, so is the number 7 greater than the number 7? No, right? So this here is actually a false statement, right? It would be true if this was an equality, right? If instead of an inequality, it was the equation x plus 3 is equal to 7, then it would be true. So you need to be careful when you have the same number on both sides and you're dealing with an inequality, right? 7 is definitely not bigger than 7, right? If this here was Pac-Man, Pac-Man wouldn't know what to do. He doesn't know if he's going to face to the left or to the right. because they're both the same number, right? So special cases with this, we do actually have a different inequality. So if this changed from this sign to this sign, right? The greater than sign with a line under it, now it would be a true statement because this statement here means greater than or equal to, right? So again, let me just show that slide that I showed you at the beginning of the lesson right here, right? So if you're dealing with these two, the greater than or the less than sign, if you have a situation where the left-hand side and the right-hand side are equal, it's false. But this here, right, it says greater than or equal to. So if I were to use that symbol instead, and I got, 7 is greater than or equal to 7, this here is a true statement because of the or equal, right? If I just said 7 is greater than 7, that is in fact false because it's not bigger than it, it's equal to it, right? And we're not focusing on that so much today, but that is something that is really important when you're dealing with inequalities, right? So if you're getting a little confused here, don't worry about it. We're not focusing there, but I just wanted to make sure that you guys are aware of that fact, all right? So what we're doing down here is they were just testing a couple of more values, right? So we already went through what happens when you test it for an X value of 7. They went ahead and also checked it for X values of 2, 4, 6, and 9. And this here is the results that they got, right? So the only one that they see that worked was when they did check 9. So it works, and they got 139 is bigger than 108, right? And again, what you're gonna find is, again, you always have multiple solutions. So if I were to check something that's bigger than 9, because 9 worked, I know that that would also work, right? So I can kind of assume that the following, right? If I were to check like the number 10, that's gonna be true as well. If I were to check like the number 25, that's also gonna be true. If I were to check smaller numbers, like I was to check the number 1, because this is false, something smaller is also going to be false. I can even go to like negative 13. That's also going to end up being false, right? So inequalities, again, if you find something that works, then usually something that's bigger than it will also work. If you're talking about something that's greater, right? You have to be careful with the inequality. But again, all we're doing today is this substituting. So if the substituting is working, you're making sense, you understand that, you're off to a good start. I think there's an example for us to do together here. So it says, for which value of X is the inequality 45 minus 4X true, right? So I'm gonna give you guys 2 minutes to try and work it out. Again, substitute values in. So this is your inequality. This time it's a less than. So you're trying to figure out which value can you substitute from the left-hand side into X to get the left-hand side being smaller than the right-hand side, all right? So people are already giving me the answer in the chat. So I'm just gonna set the timer to 1 minute actually. So again, we wanna see which number makes it smaller. So Alpha, you got it. AJ, you got it. Jaden, you got it. Jing Hao, yes, that's it. And again, just be careful with the inequality sign, right? In this case here, we're actually talking about less than instead of greater. And even if you forget which is which, right? Let's say you forget, I can't tell, is that a less than sign or is that a greater than sign? It doesn't matter, right? Because when you get to the end, you just say, okay, so is this open mouth pointing towards the larger number? If it's pointing to the larger number, it's true. If not, it's false. Okay, so I did see a couple of people get it right. So let's go ahead and see, right? Now, more people got it right than not. The answer here is 10, right? Let's check it out to see. So I would say, okay, so 45 minus 4 times 10, is this less than 14? 4 times 10 I know is 40, so 45 minus 40, right? Just remember order of operations here. You need to multiply these two before you subtract. It's less than 14, right? 45 minus 40, that gives me 5 is less than 14. So I got a true statement, right? I did see somebody ask, they said, is 9 correct, right? So 9 wasn't an option, but 9 may in fact work for this inequality. So let's just check that out really quick, right? Does 9 work? I'd say 45 minus 4 times 9 is less than 14. I end up with 45 minus 36. Is that less than 14? 45 minus 36, that's plus 4 plus 5. 9 is in fact less than 14, right? So 9 also works. It wasn't an option, but remember, with inequalities, you are going to end up with multiple options, right? You have infinite options that are going to end up working for you, right? And anybody that picked one of the smaller numbers, I would just say to make sure that you're being careful to say, okay, so right, the Pac-Man mouth is pointing towards always the larger number. So if you have to, at the beginning, draw out little Pac-Man, right? If Pac-Man is trying to eat the smaller number, Pac-Man is incorrect, right? He's always going to go for the larger of the two numbers because Pac-Man is greedy, right? Let's see, where are we? I think we're pretty much actually, yeah, this is the last slide, all right? So again, they're giving us one more example, right? This one here, maybe it might look slightly more confusing just for the simple fact that we have two x's in the inequality, right? But fundamentally, nothing is really changing here. So this inequality that it's told us now is x plus 9x minus 8 is less than 85. So again, you do the same exact thing. If I was trying to work with x being the value 4, right? The only thing you need to be careful about now is that you need to substitute in two different places, right? So I would need to take this 4 here, replace it with this x here. My pen is not cooperating at the moment. And then also replace it with this x here next to the 9. Then you just add things together, subtract and order, right? People that are kind of remembering what we did before, you might actually realize that you can make your life easier, right? Instead of having to replace it two places, right? You might say, okay, so I see parentheses here, but it's actually not telling us to distribute, right? There's no number in front. So if you have an example like this, you can actually simplify this expression to make your life a whole lot easier. So what I would do is I would say, okay, these parentheses here, I actually don't need them. So that's the same as writing x plus 9x minus 8 is less than 85. And then you use that technique that we talked about a couple of weeks ago called combining like terms. Right? So when we combine like terms, I'm basically looking to see, do I have multiple x's, right? So if I have x, right? Remember, if there's no number, it's like saying I have 1x. So if I have 1x and I add 9 more x's all together, I actually just have 10 x's minus 8. I can't do anything with that minus 8. These are different types of terms. So if personally I were the one working with this expression, I would really prefer to work with it like this instead of like this. Because now when I substitute, I'm only substituting once. I only would have to substitute the 4 into here instead of writing it out in two different places, right? But same idea, right? If this one feels more comfortable, you don't feel comfortable yet working to get to this step here, that's okay. It's still going to work using this inequality here, right? But they already did the math for us. They checked these four numbers, 4, 9, 10, and 12. They found that it was true for 4 and 9. But once we got up to 10, it was too big, right? Once we got up to 12, it's too big. So at this point, anything that's bigger than 10 is going to end up failing. Anything that's smaller than 9 should end up working, right? So I believe that is the last slide of what we're going over today. At this point now, you guys are going to be working on finishing up the activity slide here that should pretty much just have you be doing the same thing that we did today, right? So you're going to look at, for some reason this isn't scrolling for me. There it is, right? You're going to look through here, check out the values, decide if they're true or false, and just answer the rest of the questions there. All right, so it is 9:16. We do still have more than 10 minutes of the live session left, but if you think you've got a handle on it, you know what you're doing, you can head out and then just continue again until 10:30 working on finishing up the rest of this lesson.